Howdy, folks. It's Coach Primo here. We are talking about step and piecewise function. This is your introduction to it. It's the 8th lesson in this unit 5, which we've kind of dual done with unit 4 and the advanced quantitative reasoning text, which you have available online. So let's talk about some of these questions. How do hurricanes affect the weather of Texas? Well, it's obvious that we've been through a couple of them. If y'all remember that hurricane that came down and blasted Houston, Harvey, a couple of years ago and dumped probably the equivalent of, 17 Super Bowls full of water on the city, or more than that, probably 100. Anyway, hard to quantify that. The point being is it affects the weather of Texas a lot because we're right here on the coast, or a lot of Texas has a coastline. And what time of year do hurricanes typically strike? It's generally from spring to fall. And when a hurricane strikes in spring to fall, because hurricanes are only generated when the weather is warmer. When a hurricane strikes the Texas coast, what happens as the hurricane moves inland? As it moves inland, it has no way to generate more power because it doesn't have that warm water, and the moisture just goes away. So there's no way to generate it. So when it hits the land, it kind of tears apart everything and just breaks up. And when a hurricane causes flooding in West Texas, where did the hurricane likely come from? The Gulf Coast, of course. So those questions are pretty simple. Objective answers, really, but that's pretty much it. All right, great things. What are some great things going on? Okay, so had some plumbing issues in my house. This is a new video for y'all. Plumbing issues in my house, got most of them fixed, including my sink. 75-year-old house has 75-year-old pipes, and 75-year-old pipes in Texas that gets weather from the north, like Indiana that I grew up with, pretty much tears up those 75-year-old pipes. So anyway, let's move on. All right, so Texas experiences a wide variety of weather, including hurricanes. Coastal residents often feel the direct effects of hurricanes when they make landfall along the coast. Cities and towns that are directly hit by hurricane can sometimes take years to rebuild. Galveston is one such city. As a matter of fact, Galveston was completely destroyed in a storm that hit in 1900, the deadliest hurricane in U.S. history. Rebuilding after the storm took several years, partly because residents raised the elevation of the entire city, built the Galveston seawall to protect the city. Other towns weren't so resilient. 1886, residents of Indianola completely abandoned the ruins of their towns on the shores of Matagorda Bay after it was wiped away by a strong hurricane. Using the Saffir-Simpson scale, meteorologists describe the strength of a hurricane. The scale is based on a combination of wind speed and barometric pressure. Faster the wind speed and the lower the barometric pressure, the higher the rating of the hurricane of the Saffir-Simpson scale. Here is a picture of the Saffir-Simpson scales. Hurricanes that strike the Texas coast, there have been no recorded Category 5 hurricanes, which are the strongest, most destructive storms. Although many Caribbean and Central American nations have been pounded by Category 5 hurricanes, the United States has only been hit by 3. The 1935 Labor Day hurricane, which struck Florida Keys, Hurricane Camille, which struck past Christian, Mississippi, and Hurricane Andrew in 1969, which struck near Homestead, Florida. I lived through that one. That was crazy. And you can see the wind speeds in mile per hour that cuts our exact precise wind speed or categories into the five speeds. And the following table shows the year wind speed and Saffir-Simpson category for some hurricanes that made landfall on Texas coast. Table also includes some Category 5 storms that have hit the United States. Okay? Notice it goes by year of incident. Okay? So, we're going to provide a dependency statement that describes the relationship between two variables, wind speed and Saffir-Simpson category. The Saffir-Simpson category depends on the wind speed of the hurricane. Total dependent statement right there. We're going to make a scatter plot of the Saffir-Simpson category versus the wind speed for the hurricanes listed in the table. And it's done. As you can see, it doesn't take very long. There's 2 that were at below 90, 3 between 100 and 110. Actually, it's probably more than 3. Some of these dots are duplicates because some of them clock the same measured wind speed. So, but the biggest is 190, and I think that was Hurricane Camille. Anyway, Mark the wind speed endpoints for each Saffir-Simpson's category on the scatter plot. Notice that each dot that falls within the category line is on the category line. And we're going to add those lines there. The blue lines indicate the category age. Notice there's none over 200 miles an hour. So is it possible for a hurricane to be rated between a category 1 and a category 2? Why or why not? Actually, a category 1 hurricane has winds between 74 and 95 miles an hour, and a category 2 hurricane has winds between 96 and 110 miles per hour. There is not a category for a hurricane with a wind speed between 95 and 96 miles per hour. Hurricane wind speeds are difficult to measure precisely, thus most hurricane wind speeds are estimated to be nearest 5 miles per hour. Suppose a new technology were invented to allow meteorologists to measure hurricane wind speeds very precisely. If a hurricane had a wind speed of 95.1 miles per hour, what category would it be rated, and how do you know? Actually, according to the scale, there's no way to categorize that hurricane with a wind speed between 95 and 96 miles an hour, because Category 1 goes to 95 and Category 2 starts at 96. Revise Saffir-Simpson scale so that you can rate hurricanes with wind speeds that lie between the existing categories. And there you go. Pretty simple. 74 through 95, and then greater than 95 through 110, greater than 110 through 130, and so on until you're greater than 155. When graphing inequalities, how do you represent an endpoint that does not include or equal to? Use an open circle to represent it, up to but not including. Use a closed and open endpoint to revise your scatter plot for the new hurricane rating scale. And it's that simple. We don't include anything that's at the bottom because that's included in the end of the first one, or it's not a hurricane until you get above that speed. What kind of function does your new scatter plot represent? This is called a step function. All right, online store uses step function to determine shipping costs. Less than $25 is $5. In Europe, it's $10. In order total, continental United States, 25 to 74.99 is $10. 75 to 124.99 is $15. All the way up to $350 or greater is $25. Make a graph of the shipping cost versus the order total. And it looks very similar, doesn't it? Notice it has open circles at the end because the plain dollar actually starts the new step in the function. For order shipped to Europe, the shipping cost for the United States is double. Fill in the table to show the shipping cost to Europe. And use a different colored pencil to make a graph of the shipping cost to Europe versus their order total. And it's pretty simple. I used a gray pencil this time, and the shipping costs are just double the cost. If it was $5 to the United States, it was $10 to Europe. $10 to the United States, $20 to Europe. All the way to $25 to the United States, $50 to Europe. How do the two graphs compare? Simple. Horizontal segments are each parallel. Each successive segment for the Europe graph is twice as far from the x-axis as the parallel segment for the US graph. How do step functions compare to linear functions? Step functions consist of several horizontal lines or linear functions with domain that each constant functions for a small domain. Linear functions are continuous, but step functions are not continuous. Okay. I want to launch you with this. I suspect losing paper maps, but gaining GPS and online maps is a similar step function. Maps still exist, but they're vastly more useful. Not to say permanently up to date in their new form. Again, I won't be shedding any tears, but I'll keep a paper road atlas in the back of my car for another few years. I think, just in case. It's not actually a bad idea. Anyway, go ahead to Schoology and make sure you get your assignment done, folks. We want you to be blessed or be a blessing.